Now guys, let's try to understand NAT gateway use cases. So this NAT gateway will use to access the internet from the private subnet. Access your network using allow listed IP address, or enable the communication between overlapping networks. So sometime what if there is a overlapping subnets between two networks and we want to allow the communication, we can use this particular feature called NAT, and we can able to achieve this thing as well. Okay. So this is the first use case. We can allow the communication to our private subnets, whatever EC2 machine we are having in our private subnets, right? They can able to communicate with the internet. Second, you can allow access to network using the allowed IP address only. What we can do? Let's suppose we have a private subnet here and we have our on-prem data centers, right? And there is a IP tunnel, or maybe a direct DX we are using, direct connection. Now we want to allow the communication in that case from the specified range only. What we can do? We can use the NAT setup. What on in on-prem device, we can just on-prem firewall, we can allow the public IP address, that elastic IP address of our NAT gateway. So it will allow the traffic only from that particular elastic IP. So that's how we can restrict the communication. And we have a third use case. We can allow the communication between the overlapping networks. Like here, you can see we have a subnet which is 10.0.1.0/24 on my BPCA, and I have a BPCB where I have a 10.0.1.0/24 subnets, right? Now, if we want to allow the communication between these two subnets, between these two BPCs, what we can do? We can basically use the technique of NAT here, and they can able to communicate easily. Okay, so these are the ways to basically do these things, or these are the general use cases for your NAT gateway. HA we have already discussed. In HA, what we have to do? We have to basically deploy one NAT gateway here, one NAT gateway into another availability zone, and we have to create two route tables to both the AZs, and we have to basically add a default route to bus these two particular NAT gateways, and after that they can able to communicate with the internet. Okay. So guys, this is how we have to go with the NAT gateway concept in your Palo Alto firewall. Now, yes, Ketan, we can able to basically use this particular firewall as well for the same thing. And when I'll deploy the Palo Alto firewall, I will show you the same part. Okay, don't worry. So when we will see the labs, when I will integrate my Palo Alto with the gateway load balancer and all, that time I will use the NAT. Okay, now. See guys, I will not able to repeat the things. If you have to watch everything properly. I will not able to repeat. So do not ask me to repeat any topics. You can visit the video after once I will upload on the portal and ask the question into the next class. Okay. Repeat thing will not happen with me. Sorry for that. Now, see guys, see, as I have mentioned, NAT gateway is a paid service, right? So what we have to do, we have to destroy. If we have created, we have to destroy. Go and just delete this. Go here and just delete this as well. Go into this particular route tables, and generally these route will automatically removed. So we don't need to do it again and again. Okay, now see, delete the net gateways whenever you have basically created other. And guys, do not basically leave them as a running, otherwise they will charge the amount. Okay, around $1 they will use, they used to charge for 1 day. Okay, so be careful with them. Now guys, apart from this net gateway, and guys, see, in production environment everyone uses this net gateway only, but there is a one more concept. We can use the net instance as well. What we can able to do, we can able to use the net instance concept as well. Let me just show you this part properly. So this is covered, this is also covered. This also I have explained right already. And if you, let me just tell you one more time the packet flow, how the packet used to traverse when we have a, this type of setup when we are using net gateway. And after that I'll just move further. So let me use this color here. Now let's suppose this particular VM is a part of private subnet. Now this VM wants to communicate with the internet here. So what used to happen, what it will do, this particular VM will forward the traffic towards this particular net gateway. Okay. And after that, what happens? This net gateway will forward this traffic towards the BPC router. How this particular net gateway know he has to forward the traffic to this BPC router? Because we have got this default route, right? See, this PC is forwarding this traffic to net gateway because it has a default route towards the net gateway. Now this net gateway is a part of public subnet, right? And public subnet is a part of this public route table. And this public route table is telling if there is any traffic towards the internet, you can forward towards the internet gateway. So it will forward this traffic towards the internet gateway. And now this internet gateway will forward the traffic towards the internet. That's how the traffic is flowing for this net gateway concept. Okay. And now in this app server, what used to happen? Generally, as I have told you, AWS has a default BPC, right? And each and every subnet, there is a route IP address which is, let's suppose, 172.16, 1.1, 1.2, 1.3. These are the reserve IP address, right? And this is the default gateway, right? And that IP address is configured somewhere here. So this traffic will go here to BPC router, because see, here in BPC router they are using this BXLAN for the communication, right? Then it will forward to net gateway. Net gateway will do the source translation and it will again forward this traffic towards the AWS router into another BRF, then to internet gateway, then the internet. So that's how the traffic is flowing. Okay. Because see, you will not have a control of this BPC router, right? And we are not sure how this AWS is using it, right? But definitely, as a general explanation, like I have checked into couple of blogs, they are using VXLAN for the communication. They used to create a multiple VRF type of instance here on this BPC router. Okay, cool. Now let's move further and let's try to understand this net instance concept in your AWS. So guys, see, there are the customers, if they don't want to use the net gateway, means if they don't have a trust on AWS like AWS net gateway. In that case, what you can also able to use the net instance here. You can use a dedicated EC2 machine. And in this particular EC2 machine, what you can able to do, you can able to configure the net related services. Now this machine will act as a net gateway device. This machine is any machine, like you can use Amazon Linux, you can use Red Hat Linux, like any machine you can use here. Only the condition that machine will able to perform the net. That is the requirement, right? What I will do, I am going to use the Amazon machine for this particular lab. Okay, so now let's try to understand what is net instance concept first. So net instance is a EC2 machine running the net software, means this is a one of the machine which is running the net software, means that machine is able to perform the net related task. It is not recommended at all. What is the reason? Because there is a one net AMI of Amazon Linux, and that AMI is going to end of life soon. That is also one of the reason it is not recommended. You can use the latest version of Ubuntu VMs as well as a net AMI. Okay, it will work fine, but it is not recommended because it has a issues with regards to the bandwidth. If you need a high bandwidth, right, what you have to do? In that case, you have to basically choose a very highly available machines with which have a more CPU and more RAM, right? Because then only it can able to perform the net related task. NAT EC2 can be launched using the Amazon Linux NAT AMI. Update private subnet route tables. We have to do the updates on our route tables. For internet traffic, set the target as a net instance ID. Speed based on the CPU. Memory means if you need a high bandwidth or high speed, you have to select a machine with the high CPU or the high memory. They are not designed for doing the net related tasks, and guys, they are not the specialized on doing this net related task. That is also one of the drawback of using these machines. We can allocate one elastic IP. The route table associated with the private subnet sends in sends the internet traffic from the net instance, like the route table associated with the private subnet sends the internet traffic from the instance in the private subnets to the net instance in the public subnet, and then net instance can send the traffic towards the internet gateway. Means what what is the meaning of this statement? Let's suppose we have this machine here. If this machine wants to communicate with this particular web server, what it will do, this machine will forward the traffic to your AWS BPC router, and after that this particular traffic will forward towards the net instance. The net instance forward back this traffic towards the AWS router, and this AWS router will forward towards the internet gateway, and internet gateway will forward this traffic towards the web servers. This is the traffic flow. Your first packet will go to AWS router. Now from this AWS router, it will reroute the traffic towards the net instance, which is a part of the public subnet. And from this net instance, it will go towards the AWS router again. And from this AWS router, it will go towards the internet gateway. So that's how the traffic is flowing. And now guys, your all the net related tasks happened here. Means let's suppose this machine wants to communicate with this server, then this is the packet. IP address is 172.16.2.100. Source IP address, and the destination IP address is 151.7.100, which is a public server over the internet. Now this is the packet reached to this net instance. Now this net instance perform the source address translation, or it will perform the port address translation, right? And what it will do, this particular source IP address, it will basically change, and the packet after the net, it looks like that. 33, 33, 33, 33. Let's say this is the elastic IP address. This IP become the source, and the destination IP is 151.7.100. And guys, it will also perform the port randomization, just remember. Okay. Now, now do one thing. Now let's try to basically do this thing also practically. So guys, I am already having these 4 VMs, so I'm not doing anything with the VMs. I have a route table, so this route table I will modify. Okay, now I go into my EC2 machine here. Before that, let me just tell you, let me just go through with all these steps first. Okay, let me just cover this theoretical stuff. The net instance must have internet access. Means, guys, whatever VMs we are using as a net instance, that particular VM should have a connectivity with the internet. Means this particular VM is a part of public subnet. It has elastic IP address, and whatever that particular subnet, if it's a part of route table, then route table need a default route towards the internet gateway. So it must be in a public subnet, a subnet that has a route table with a route towards the internet gateway, and it must have a public IP address or an elastic IP address. We have to disable the source and destination check. This is the most important part. Each EC2 machine perform the source and destination check by default. Now, guys, what is the meaning of this source and destination address? Or what is the source and destination check? Tell me one thing, one journal scenario. See, we have this particular setup. Let's suppose we have this setup. Okay. Now, when this VM is generating any traffic, so this is the packet, right? Packet have 172.16.2.100. Let's say this is the IP address, source IP, and the destination IP address is, let's say, 150.1.7.100. Let's say source port is 3050, and let's say they are communicated over SHS, then destination port is 22. Now this is the packet is generated by this EC2 machine. Now this packet is reached to this net instance. Now what happens? See, when this machine will receive any packet into the interface or whatever the port it is having, whatever packet it will receive, what it will check. What is the source IP address? And what is the destination IP address? Means it will perform the source and destination IP check. And what is the source right now? Source is 172.16.2.100 and destination is 150.1.7.100, right? Now, guys, this particular machine is receiving this particular packet, right? So, is this machine accept this traffic? By default, it will not accept because this traffic is not coming for this machine. It is for this server. What it is checking in source and destination IP, it will perform that check. Whatever traffic is receiving, it is a traffic destined to this EC2 machine or not. Like right now, see, right now it is not like that. If I am just sending some traffic, so that traffic go to into your PC, then your PC will reroute the traffic towards this particular web server. It's not like that, right? It will not accept by default. Means all the machines generally they will block all the pass through traffic, the traffic which is passing through this machine. They will only accept to the box traffic, means the traffic which is coming for you, which is generated for you only. And this time this particular packet is a pass through traffic, right? So what we have to do, by default they will perform source and destination check, and we need to disable that check, then only it will work. I hope everyone understood this, what is source and destination check. Okay, so this is the one thing which we have to understand. Disable source and destination check. We can attach a security group on the net instance and the ACL. Means right in with the net instance we can able to basically attach the security group as well. Okay, net instance we need to manage by ourselves, means management is done by us only. If anything is happening, we have to do the troubleshooting. We can use the script to implement this HA with regards to net instance, because here what we have to basically implement two net instance if we are having our subnets spread across two availability zones. Route tables changes based on the failures. We can monitor the instance health using the CloudWatch or the monitoring the traffic using flow logs. works across the DX, BPN and peering connection. So guys, when I have told you, right, it can solve the problem of overlapping subnet. See, your NAT gateway is not going to solve, but this particular NAT instance can solve this particular problem as well. And we can able to spread this setup across the direct connect, BPN, or if there is are any peering connection, just remember, okay? And guys, go through with these particular documents as well, whatever I have mentioned here, okay? Just remember. Now, read these three articles. They are very good. You will get the idea. Now, for the lab purpose, what we have to do? Let's do the lab work. In the first step, we will need to select the net AMI and we have to launch that net AMI. So what we will do, I'll go here. Net instance. 1 minute, let me refresh. Select, launch the instance here. Give the name net instance 01. Go into this search and type net AMI, hit enter. You can go into this community section. In community section, you can able to see these three net AMI, so you can use any of them, but I am going to use this one. You can use this one because it is a verified by the AWS. You can also use this one, but I will use this. Select. Go down, go down. It is using the T2 medium, right? It needs around 2 virtual CPU and 4 GB of RAM. It is not available for free tier. Just remember, guys, free tier availability is not there for this VM. Key pair, if you want to log in, you can use the key pair as well. So let me use the day 5. It's day 5 key pair. In network settings, I will select my BPC and I will just put this VM on my public subnet 01. Auto assign public IP address. Security group, let me select the existing one. Let me just allow all the traffic. Advanced, if you want to configure the IP address and all, let me just go 172.16. 1.249. Let's suppose I will just go and launch the machine. So first task is done. We have basically we have selected the correct AMI and we have basically launched that particular AMI. Even though guys, see, you can able to use some other journal Linux images as well. Like you can use the Ubuntu as well, right? Let me just tell you one. There's are articles like AWS net instance. I have seen there is a one article, like you can see if you will go here, you can create the net AMI, means you can create your AMI as well. What do you have to do? You have to install these particular packages. If you remember guys, if somebody have joined my Palo Alto classes, I used to basically explain like when we used to install this Ubuntu or EVNG over the Google Cloud, right? I used to enable this the same functionality here by using these commands, right? So if somebody has done so, you can also follow this article. If you want to create your EMI, your net instance, you can able to do it by yourself as well. Okay, but I'm not going to explain in this way because otherwise you got confusion and all. We can use the built-in feature which is already available there. Okay. There's one question. It is preferable to use two NAT gateways. Yes, if you have a like two availability zone, and both availability zone has a have your private subnets, then it is recommended to use two net gateways for the high availability. Okay, now go. Let's see. Where is that fifth VM? Let me refresh. Go into EC2 dashboard again. I have 4 running machines right now. But where is this net instance one actually? This failed or what happened actually? Let me launch again. I'm not sure what happened. Net instance AMI. Search here. Net AMI. Enter. Go into this community section. 1 minute. Give me 1 second. Let me just open into new tab. Running. I just have only 4. Somehow I think it is not created. Okay. So I need to relaunch again. I will use this NetAMI. Just select here. Key pair. Let me use this demo 05 key pair. I will use the public subnet 01. Security group which is allow all. I will leave advanced configuration like this only. Let me go and let me just launch. Successfully initiated. Go into this instance. Okay, see this time it is launching, so we will wait for some time. There are a couple of questions on the chat. Net instance, both AZ are required. Yes, we can go with the both AZs. But see, Bisal, it is not recommended to use net instance, right? AWS is recommended to you go with the net gateways. So if Suraj, like if there is any VM is failing, generally you can able to see at the same place. Okay. When it is creating, you will get that status check and all right. That time you can able to see. Okay, it is initializing, so we have to wait. It will take some time. This is the public IP address. All these settings are good. Now let me just do the changes. I can go with that only for this particular route tables. I will not do any changes as of now. Let's go here. See, it is running right now. Not running. It's still initializing. It will take some time. Okay, so we have to wait. Now we have to disable source and destination check. Then we have to modify the security group. But generally right now we are using allow all traffic, right? So we can able to, we don't need to modify anything. Launch the net AMI on public subnet. In security group, if you want to put some restrictions, you can go like that. You can allow SHS, STT, and ICMP traffic. Disable source and destination check and add the default route on the private route table via the net instance. Done. This is how we have to do the things. Okay. Let's wait here. Still it is initializing. It's taking lots of time. This is how we can able to enable this change source and destination check, right? You have to select this stop, click on save. So this is how we can able to basically configure this source and destination check stop, or this is how we can able to disable. You have to select this net instance, action, networking. You will see here change source and destination check, and you have to click on stop. Stop to allow your instance to send and receive traffic when the source and destination is not itself. Okay, just remember. And with regards to the route tables, go here into your private route tables, routes here, edit the routes, and this time you can remove this, add the new route, and this time what you have to select this instance, and you have to select the instance ID, which is net instance AMI. Go and save. This is how we have to update the route tables. So we have a two route tables for private subnet. So I go here and let me just update this details into both of my route tables. This is how we have to do the routing related changes. Okay. Now let's see if I'll go here. Let me do the ping to Google. See, ping is working. And go here, ping to google.com. See, ping is happening. Apart from that, let me do one more thing. Yum update -y. Right now, it is not happening properly because I'm getting this redirect messages. What happening? This machine is not processing the traffic. So let's see. It is now in a running state. Go into actions, networking, change source and destination check, which is already stopped, right? Now we are good to use this particular thing. Go here, run this command yum update -y into this. Go and just try to ping. So ping is not working, which means there is some issue. Okay, so let me do one thing. I'll go here, I'll select this IP address, and let me just take the access of this particular net AMI. New session, EC2-user, put the public IP address, select the correct key, which is AWS day 5, login. So you can see I got the access ping to google.com. See, ping is working from this net AMI. Even though, let me go here, let me just access via this, because this AMI is created by someone else, right? So this is the name of the person and all who has created this particular net AMI, right? Username, I'm not sure what is the username. Let me try admin. It works. Not. No. EC2 hyphen user. No, it is not happening right now. If I'll go into this particular website, so we can able to check the details here as well. You can able to check the details if you want to, because see, we are using this particular organization AMI, right? So that is the reason. If there is any issue with this AMI, it will not work. Okay, sometimes this is also we have to consider. If whatever AMI I'm using, if it has any issues, then then traffic flow will not work properly. Just remember. And also that is the only reason, I hope that is the reason it is not able to communicate, right? So what I can do, let me do one more thing here. Go here. Okay, let me launch new machine. Net AMI 2. Search for net AMI in community section. Just use this one. This is T2 micro, freely available. Use this day50 key pair. Deploy this in BPC01 in subnet 02, which is a public one. Allow all the traffic. Go and just launch. Just wait for this machines to come up properly. NetMI2 is still in pending states. It is initializing right now. Let's wait here. Initializing. So we will wait. This time it will work properly, I know. Security group, everything is fine. it is taking some time to launch, so we will wait. Meanwhile, let me just select this instance ID. Okay. And I'll select this machine here. I'll go into action networking, change source and destination check, click on stop, save it. Go to into route tables, route here, edit the route. Instance, select the instance which is netami2, click on add, go into the second one, route, edit, delete this instance and select your netami02. Refresh. It is still initializing, so we have to wait. Meanwhile, you can see it is start pinging, right? So I think previously we were using the wrong AMI. Okay, you can see it start working now. From here also you can see, you can update and there's no dependency. You can ping to google.com, see ping is working, right? You can install any packages, yum, install, let's suppose tree -y. See, it is installing the things. Okay, so this is how we can able to do the things. Now from this machine you can go with the trace route as well if you want to do trace route 8.8.8.8. So you can see traffic coming from this machine. It is going towards 172.16.2.28, which is a NAT AMI2 IP address. Okay, you can see this is the IP address, right? And after that, it is moving towards this IP, then this, then this, then this, and it is reaching till the Google. Okay, so guys, see, whatever AMI, I think this is the one we were using. It is having some issues. That is the reason it is not able to basically work properly. Okay, so use that one. Let me just show you one more time. Launch. Type here AMI, net AMI into community. Use this one. Okay, do not use this one because you have seen we have faced the issues, right? If you will select, like, even though we don't have any documentation or as well for this one. Okay, cool. So guys, this is how we can use the net AMI concepts basically for doing the or for achieving the network address translation related task. Now, see, if whatever VMs you have created here, now what you have to destroy them. Okay, so what I will do, let me just select all of them and let me just terminate. I don't want to use them. It's terminated. And it will basically delete all the VMs. So this is how you can able to destroy the things. And guys, remember one thing, you can always go into this EC2 dashboard and from here you can able to track the things. Right now there are two elastic IPs. Soon they will also get deleted. If they are not able to delete it, then what you can do, you can go here one by one and you can release them. One is released, release another one. Always check this particular EC2 dashboard and you can able to see everything. Key pair, We have a multiple key pairs, right? So guys, I just want to use one key pair, or let me just delete all these key pairs. I will just use this demo key pair. Okay, I don't want to just type a delete, and they will just delete it from here. I just use this demo key pair. Let me go into my main system and I will just delete this as well. Because they will create lots of confusion. So that is the reason I'm just deleting them. And I will just use this demo key pair for all my practicals. Cool. Now, see, in route table, so go to into BPC and just go here and just delete your BPC. Type here delete. To delete the BPC, you will get here what you have to type into the field. Then only you can able to delete your resources. Just remember, go to into BPC dashboard, check your status. It is deleted successfully. Go to into dashboard, refresh the dashboard, and you can able to see. You have to see if there are two net gateways are running or not. See, they have deleted already, right? So always check this thing from here. Like net gateway which is already deleted, we don't have anything else apart from that, right? So things are good. Go here into EC2, check the things here, and from here also you can see things are deleted. Net instances is already deleted, but they will take some time, okay, to remove from here. So guys, this is what which I wanted to cover with regards to the net related things. Now these things we have already seen, right? Bring your own IP and all these things I will cover in future. I will not cover today. Okay, DNS and BPC I will also cover once I will complete your IPsec, VPN or the transit gateway part, because these are the very important topic, this BPC, DNS and DHCP. Okay, so this is what which I wanted to cover with regards to your day 3, day 4 and day 5, guys. Okay, just save, let me just save this file, close it. Yes, okay, cool.